Okay, back again. The planning is working out really well. I planned that it would take 14 little pieces to make a nice ring around the core, and sure enough, when I put them together, 14 little pieces fit. So here's a still photograph of the piece before I put it in the kiln, because this is a tiny bit more complex than just a stack of color rods. I'm actually preheating it in the kiln a bit to give it a little more of a fighting chance to work correctly without exploding. Probably isn't necessary, but hey, you never can be too careful in this business. I've also done something that was a little bit different. Usually I make the core and then cut it off on the cold saw, leaving a nice exposed face. In this case, I cut off the punty with a diamond shears somewhere in the clear, leaving a kind of a blob of clear on the end of my core, and I'm suspecting that that blob of clear will be pretty useful when I preheat the blob and kind of like melt it over and get all the little outside guys welded in place. Might actually be a helpful way to get these guys under control. 14 small rods on the outside of a fairly large inner core is a pretty tricky thing to deal with, because the rods are going to want to just go everywhere. They're going to want to just buckle and fall off, and keeping them under control is going to be somewhat of a challenge. I've never done this one before, so here goes. I'm preheating my punty, getting it ready. This is an old punty that I'm reusing, an old punty and moil that I'm reusing from another project. And hey, why not? Why waste glass? That's why I usually, when I'm done with a pull, I usually kind of clean up the pullers and give them a little bit of annealing so they don't explode when I put them back in the flame. So anyway, it's kind of also saves time. It actually does take a little bit of time to make one of these things, and having it all pre-made not only avoids wasting glass, but saves a little bit of time. So I'm going to be using my custom forky tool. Very nice to have a machine shop and be able to just whip out custom tools whenever I need one. Even a simple thing like this can be very useful. So I've got to be really careful when doing this. Careful and slow. Slow and careful. It is kind of heavy, and dropping it at this point would not be a fun thing. So let's get this guy's end in the flame, and then I'm gonna preheat the end of this thing and just see. I'm using the torch at an angle so that I can concentrate the heat right on the end that I want to fuse when I'm using the larger Mirage flame. I think I'm going to switch to the more focused flame and do a little bit of welding here with a small rod, a 3mm rod. pieces are not perfectly uniform in length. I have to kind of like squish everything around a bit. Okay. One of the next projects that I'm planning on making will be a simple little rod nipper, so I can kind of like a rod nipper with a fence, so I can more accurately cut these pieces to size. This isn't going to be a problem having them slightly the different size, because you know the punty end of the piece usually ends up unusable anyway, but I always like to do anything to improve precision. So not enough to stick. Hit the target and stick it butt good. Give it just a little bit here. Try to make sure that my somewhat dicey weld stays secure, because it's not perfect yet by any means. So now Mirage hand torch is sometimes temperamental when restarting. I don't quite understand that. I'm going to weld some clear on the far end. Because these, especially with thin rods on the outside, these things will explode. Shouldn't say explode, they just kind of like fall apart, and all the little thin rods just go off on their merry way. Okay, so that hopefully will stabilize the end. Back to rotation mode. Of course, this is the most unstable that the piece will ever be, with the greatest risk of catastrophic failure. So, as I manage to get some heat into it, I'll be able to get it to stabilize a bit and tag together. So, up here on the tool rack, I think that's, looks like it may very well be stable enough to take the metal off. Well, looks like the torch took the metal off for me. Even though this is stainless steel, it's no match for a glassworking torch. Glassworking torch will just melt it and destroy it in no time. The end looks like it is stable. Get the rest of the safety wire off. Go back to the punty end and make sure that it doesn't get cold. The piece is a tiny bit off center, but I don't think that's going to be a problem. Nope. Okay, I'm going to get the mag flame going now. And I'm going to try to kind of gently finesse some heat into this guy. I need to get the outer guys fused in place. At this moment, even though the core has been in the kiln, the core is dangerously cold, and the outer parts are dangerously thin. And so, until it's all tagged together, this whole thing is a bit of an unstable mess. The outer rods, especially being as thin as they are, will bulge out given the slightest provocation. So I'm going to take it over to the squeezer and just, I guess I'm not. I was trying to anticipate in advance what size of squeezing dies to use, and ended up making a bit of a error in prediction. So I'm gonna put the piece in the NQALHA, let the assistant take over. And switch to a more appropriate size of squeezing dies. Now, I could have used the iris style dies, which squeeze any size, but unfortunately, the iris design introduces a twist. And for this pattern, I wanted to try to, it looks like it might be a little bit better. I wanted to try to avoid twist in this pattern. Yeah, that'll work a little better. Once again, I'm using the mag flame, but it's not turned up all the way. It's still a fairly mild and cold oxidizing flame, but it is a large surface area of torch face. And so I'm using a colder, milder flame over a larger amount of surface area, hopefully to get a little bit better chance at having heating uniformity. And I'm seeing some of the rods starting to buckle, so yeah, that gives me just a bit. I'm not trying to squeeze a hexagon. This piece will be round cane when it's pulled, but the hexagon dies in the squeezer can be used to gently nudge something into near roundish kind of shape. Blacksmiths do this all the time, although they don't have a 6-axis squeezer. It'd be pretty cool to make a 6-axis squeezer for blacksmithing, although it'd have to be a lot more heavy duty than the glass version. But blacksmiths use a 2-sided hydraulic press to incrementally form a cylinder, so I should be able to fairly easily use a hexagonal press. And yes, I could be doing the heating on the NQALHA, but this requires just a little bit more control, a little bit more finesse. It's not quite the mindless work that the NQALHA is excellent at. I think I'm starting to get a pretty good tagging going on here, so now of course the core is still cold. It's nowhere near ready for pulling. But the important thing now is to get the outer ring tagged in place, fused in place, sticking to the core, and then try to drive out some of the air. Got to make sure to not neglect the attachment point. I don't want this thing falling off the punty. I believe that successful fusion has been accomplished. And it is starting to droop a little, so the core is starting to soften. Now, just soaking in some heat. Now you can see how big my moil is that I'm building this piece from, and this is intentional, very intentional. I've found that the bigger the moil, the more I can control the pull and the more useful yield I get out of the pieces. Okay, getting a bit of twist, going to reverse direction when it's at the high point. Trying to control twist on this piece, although since it will eventually at the end be cut up into slices, it's not the most ultra-critical thing in the world to avoid twist, but I'm trying to practice, trying to learn how to use the NQALHA and the paddle and handwork to make an assembly without twist, because I'm sure there will come a time when that's needed. Like when I make my hexagon, because a hexagon ain't round. You don't want a twisted hexagon. So, slow as it goes. One of the nice things about the NQALHA is being able to just let the machine do the work, let it take its time, use a relatively cold flame relatively far from the workpiece, work in the far flame of a cold flame. I'm trying to avoid overheating the outer surface while I soak heat into the inside. Okay, reversing direction again to control twist. I'm going to switch to handwork as it starts to get a little bit loose. It's a little more pleasant. This is November in Northern California, and it's a little more pleasant working in the hot shop on a cold day. Working in the hot shop on a 100-degree day is something. I'm sure that all the glass workers who work in hot areas know exactly what I'm talking about. Squeeze, rotate a fraction, squeeze, rotate a fraction, squeeze, rotate a fraction. This one should come out pretty interesting. I've never done one exactly like this before. And just as a kind of a side note, a kind of a philosophical note, when I started making murrine, it was all experiment. It was like, wonder what would happen if I did this. Oh, that came out cool. Oh, that didn't. And now that I have a bit of experience doing this stuff, I'm starting to move more into planned design, trying to anticipate, trying to actually design to a plan instead of just throwing some stuff together and seeing how it comes out. So this thing started with a CAD drawing, and a lot of these pieces are I'm attempting to make them to dimension using calipers and reference pieces that I can gauge against. Eventually, somewhere on down the line, I'd like to continue increasing and improving my precision. I don't know if it'll ever be possible to do glasswork to machine shop precision, but always the open question, how precise could I make it? And what kind of techniques would be required to make glasswork more precise? The squeezer is definitely an important step in making glass more precise, because trying to make patterns like I make in handwork, yeah, I'm sure it's possible. I'm sure there are handworkers out there with the skill to do it, but very good murrine makers have commented that there is no good hand technique for making a hexagon or a triangle. I'm just trying to fuse them all together and keep them under control. It brings up a comment that as I've been learning glasswork, I've heard different expert glassworkers giving opinions on how to avoid bubbling, boiling, degrading, destroying sensitive colors. And one thing that I heard kind of early on in the adventure from one of my teachers, that start heating the sensitive color slowly and gently, and then once you get it up to working temperature, then you can be a little more aggressive with your heat. And I've always wondered, you know, what's going on there? Is that really true? And the more that I learn about how glass behaves, I think the more detailed explanation of what's going on there, when the inside is cold, or actually when the entire rod is cold, and you hit it with a really intense flame, it's real easy to overheat the outside because cold glass is an insulator. And so you're heating the outside to a blistering temperature, and I do mean blistering because that's what happens to the glass rod. It boils and blisters. But if you're able to heat it slowly and get it to working temperature, as glass heats, its thermal conductivity increases. So it becomes easier to soak the heat into the core as the hot glass becomes more conductive on its surface. And I'm kind of noticing that when I'm doing these murrine assemblies, that as I get more heat into the core, I see less evidence of degradation on the surface as I use more and more aggressive heating and more aggressive flame. So I'm just trying to finish up all the little cracks and little weird spots. It's almost ready to attach the puller. Yeah, I'm moving closer to the torch face, getting a little more aggressive with my heating. And seeing pretty much no evidence of boiling, bubbling, degradation, maybe the tiniest bit, but so far it looks really good. The end is always the problem because it's exposed to cold air. It's a heat sink. The heat is all flowing out the end. Well, that I'm thinking that bad boy is uniform. At least uniform enough. Close enough for rock and roll, as they say in the rock and roll business. So that is pretty uniform, pretty cylindrical, pretty smooth. Ready for the next step. So now, got my other end puller coming out of the kiln that's been pre-built and preheated, also with a very generous moil on the end. This is not a super big pull, so I may not need my protective gear, my chrome suit and face shield, but it is getting a bit toasty out here in the hot shop. For those who have never worked on larger pieces of hot glass with a Delta Mag, radiant heat is real. I'm applying most of the heat to the puller, getting the puller ripping hot, getting my murrine piece hot enough to stick, but don't want to get that too horribly hot. And it looks like I've got a great weld. Looks very uniform. And as I said before, I'm thinking about trying to develop a technique of pulling on the NQALHA. I've made, the puller is still a little bit hot. I've made some preliminary progress in figuring out how to pull on the NQALHA, but results have been minimal. It's still out of control. I still don't know what I'm doing. And if I need to get work done today, I need to go with what I know. I do believe that it will eventually be possible to develop a technique of pulling on the NQALHA. And as I said in the previous video, I'm preferentially heating the ends because they're going to be the troublesome part, and I want to get the smallest knuckle I possibly can and the most usable yield of material. I can feel it starting to get soft. Preferentially heating the end, but also remembering that it's important to keep the center uniform. Uniform heating is the key to making this process work. Start the pull. it's looking good. So I'm going to clip out a nice center section here. Put this knuckle in the kiln. Get this one on the NQALHA. Get this section in the kiln. I have in the past attempted to pull down my knuckles all in one pull. Haven't had a lot of good success with that, because while I'm working on one, the other one's getting cold and it's getting kind of long and it's getting kind of heavy. So at the moment, I'm working on this technique, which is to get my good section out of the middle then punty up and pull down the knuckles. It's a lot more manageable doing it this way. Okay, I'm going to switch to handwork. The most perfect pull possible is a uniform single heat pull. Trying to do incremental adjustment like this, it's tricky. I'm getting better at it, but the really, really high quality cane that I make is the stuff produced by a single heat and a single pull, although for where this will go in the project, I'm sure this piece will be fine. It just, the search for perfection continues, and at least at the moment I don't have the technique to pull a perfect cane incrementally. But, you know, not that bad. The result comes out pretty good when it finally all gets connected together and squeezed and sliced and squeezed and sliced and Okay, well, one thing I've learned about this technique is kind of like quit while you're ahead. It ain't gonna get perfect. Actually, I'm gonna use the diamond shears here. And that's a reasonable piece of incrementally pulled cane. You always hope for better, but sometimes you just have to take what you get. I'm going to clean up the end of this punty a little bit so I can reuse it. That's probably clean enough. Okay, so one more knuckle to pull down, and with any luck, I will have a sufficient yield of good material to move on to the next step. Concentrating the heat on the big part, because if it's going to explode on that end. By attempting to get it on center with the paddle, I can kind of feel how soft it's getting. So when attempting to pull down a knuckle, it takes a lot more heat on the big part than you would imagine. I mean, it's intuitively obvious that the big part requires more heat, but the problem, at least for me, as I'm learning this, that even knowing it takes a lot of heat, well, it takes a lot more than that, even when you know it takes a lot. And it's very easy when heating the big part of the knuckle to overheat the cone-shaped part just immediately to the right of the larger part. And so you have to put the heat a little bit further along, a little bit closer to the moil than you would initially imagine, because it's very easy to overheat the thinner part. So I am actually pulling on the NQALHA a tiny bit. And like I said, I have little confidence in my ability to complete the operation on the NQALHA, so I'm going to leave that for the future. I do believe it will be possible someday. When I'm doing the incremental pulling, I'm not heating the glass very hot at all. Heating it barely hot enough to move and applying significant pulling pressure. This helps me keep it under control, and it also has the side benefit of straightening the piece, which is always a nice thing to do, even though when this piece is actually used, it won't need to be absolutely straight. A little bit of twist will not affect it the way that it's actually going to be used, but still, I always like to practice making them straight. Another thing about pulling that I'm sure experienced pullers all know, but for someone who's just getting started at this art form, pulling is very nonlinear. If you're pulling a piece of glass that you're pulling fairly, it's not like super soft. It's kind of soft, kind of intermediate soft, soft enough to pull, but not really super loose. When you start pulling, it'll feel really hard. And then very soon, it comes up on you quick. Very soon, it'll get way too thin, way too quick right now. And that's another one of the many nonlinear behaviors of glass. So, while that thing is heating, I'm just cleaning up the punty so I can reuse it. That does it for today's video. Thank you for watching. It's been fun.